Welcome to the project demonstration of solar power based maximum power plant tracking system using SEPIC Converter. So here the main application of this project is we are going to do the MPPT, that is a maximum power plant tracking using the SEPIC Converter. There's a main feature here to charge our battery pack. So the battery pack ratings are 12 volt 3 amp we are using, and coming to the solar panel rating is we are using 12 volt 10 watts. So for easy transportation purpose we are using the two 12 volt 5 watt solar panels which are connected in parallel. So we'll get 12 volt 10 watts of DC output. So the solar panel ratings are already mentioned in this one. So here the solar panel which we are using is a 12 volt solar panel, though it can provide us the maximum voltage of 17.4 volts. So here you can see that 17.4 volts and 5 watts. So when we place these solar panels under the full sunlight, these solar panels can get up to the 17.4 volts. So in that one actually we required 14.5 volts, which is sufficient to charge our battery pack. So in our project the load is battery to charge this one, and to discharge this battery pack we have connected a motor here. In this version we have added extra load to discharge the battery, to charging of the battery through this SEPIC converter using the MPPT concept using the solar panel. That will be done our microcontroller PIC16F73 microcontroller, which will continuously measuring the voltage from the solar panels. So whenever the voltage is greater than 14.5, then in order to maintain the power, means equal to 5 watt, consider 5 watt from the solar panel and 5 watts for the solar panel, so totally 10 watts. So in order to maintain these 10 watts, then if the voltage increases, then the current will be decreases. Then this will going to get the low currents with high voltage, which is not equal to the maximum power, as we need the 10 watts in equal 14.5 volts with equivalent of currents to reach 10 watts of power. Then only we can get the high efficient manner of the power to charging of this battery pack in less time. So if you get the more voltage, there already the buck converter will do the 14.5 volts buck converter, and then we are going to get the maximum of current. So reduction of the output voltage from this solar panel, and to make that voltage to charging of the battery pack, that involves 17.5 to 14.5 with help of our SEPIC converter, that is called as the MPPT maximum power plant tracking. Means we are reducing the voltage and parallelly the current will be increases, so both meet at a point of maximum power, means 10 watts of power. That is called the maximum power plant tracking continuously by measuring the voltage from the solar panel. So in this version we have added the solar panel voltage monitoring and current monitoring and battery voltage monitoring and current monitoring with help of these sensors, and these are interfaced to the PIC microcontroller. And this is a SEPIC converter design mainly, which will acting as a here buck converter, mainly to reduce the voltage, to make it the output voltage to sufficient to charge a battery pack, and make that to sufficient current to reach the maximum power, means equal to 10 watts. So this will consist of an inductor with one MOSFET and capacitors, and here this is the transformer, but here we are using this as an inductor here, as the transformer consists of copper coils. So to get the maximum power and while doing the MPPT operation, so if you use a low rating inductors, then they may get heat up. So in order to eliminate that, we are making use of this transformer to provide the maximum power while doing the buck operation in order to eliminate the heating operation. So that will be achieved by our microcontroller, and continuously we are going to displaying the status on the LCD screen, and we have interfaced these sensors at A0, A1 and C2 for this MOSFET, and C0, C1 for this C0 and C1 for this buck converter along with the SEPIC converter here. And next the load is directly connected to this battery pack through the switch, and here we are providing alternate source to charge a battery, as if is there any like low intensity of the light available on the solar panel. So then if you want to charge a battery with 230 volts of AC grid voltage directly, so this is a transformer. Actually this is not the part of the project, this is only for safety charger for the students while execution of the project. Just disconnect this. Okay, there you can see the T by C over here. Disconnect this and connect the transformer over here, and now on the power supply to this. the light indicated showing the status of battery is charging. It will get full charge in a duration of 6 hours minimum, 8 hours maximum. Till the duration, keep the battery under charging for flawless and without any disturbance of output. And after that you can disconnect this. While project demonstration, you can use only solar panel output. See, so let me explaining the flow clearly from input to till the load output in our project. See here, the solar panel input was given as input to this voltage and current sensors over here, and parallelly that is given to this MOSFET board which is doing the MPPT along with buck converter. So the output from this is input to our SEPIC converter, and the output from this parallelly given as given through these components and to this charging circuit. You can see due to the low light intensity, we can see the low light intensity from this LED indication means the charging voltage is very less due to this low intensity from this solar panel on this solar panel surface. And here this is the interfacing connection to control this MOSFET, and this is the interfacing connection to control this MOSFET over here, and this is the voltage sensor to check the voltage and current sensor to check the battery voltage levels, and continuously measuring that on the output of the LCD screen. So this and this one is the load directly. So if you want to discharge the battery, just on the switch so that we can discharge the battery. So let us check with the demonstration here directly, just on the power supply to this adapter here, and so what the welcome message displayed, and now we can see the solar panel voltage. Right, so we need to connect this solar panel at this slot, and output of this buck converter, this SEPIC converter is input over here. Right, okay. So after placing these proper connections, now let us check with the solar panel voltage is 2.5 volts and current is 0.0 amperes, and battery voltage is 11.8 volts and battery current is 3 amps we are getting over here. And here this 3 and 2 is the duty cycle that will be increased whenever the voltage is more from this solar panels, and the next here 0 volts is nothing but the SEPIC converter output voltage we are going to get. So let us place more lighting on this solar panel. So you can see the voltage is getting increased. Right, so we place the more lighting on the solar panels, so the voltage is getting increased. Okay, and whenever the voltage crosses some value around 5 to 6 volts, then we'll get the sufficient current from the solar panel. So to get the perfect current, just we need to place these two solar panels under the sunlight, and then whenever the voltage crosses threshold value, automatically this SEPIC converter will do the buck operation to get the maximum power point tracking, and this duty cycle and this voltage value will be increased. How much of voltage is done with MPPT voltage. Okay, and coming to the load, just by connecting this we can reduce the battery voltage, means we can discharge the battery. So that is irrespective of this SEPIC converter and all, is independently connected to this load directly. So after discharge the battery pack, you can place the solar panel under the full sunlight. There we can see the light indication, as well as the battery will be charged from this MPPT concept, but at that time we should on this. Okay, so when we on that, then only it will get the MPPT operation to charge the battery pack. Right, thank you.